Hi students, I started a new tutorial on e-commerce order processing system using AWS Lambda and SQS. So why I choose this concept? Most of the AWS Lambda, like most of the AWS projects are depends on this concept, like Lambda and SQS combination. Okay, if you know this concept, then you will, then you can handle any Lambda related projects easily. Okay, so the flow diagram look like this. A request comes from the different sources. Just imagine like a API. Okay, so the API send a request to the SQS, and the SQS send the request to the Lambda. Lambda process this request. Okay, so if this SQS contains the data, that data will store in the database. Okay, whatever it is. Okay, so this is the actual flow. Mostly, if you search in the online, most of the projects contains this structure. Let me show you. Okay, AWS. Okay, I'm not searching like AWS Lambda ETL architectural diagrams. Let me search it. Okay, so if you see, mostly we have the lambdas. Okay, let me add SQS also. Yeah. Let me open any one diagram. See here, this is the lambda, and it is receiving the message from the SQS. Let's open this any other one. Here also see, this is the lambda and receiving the message from the SQS. Okay, so most of the lambda projects looks like this only. Okay, if you know this concept, then you can handle AWS Lambda related projects. Okay, I will explain you step by step. I will explain in two ways. One is like manual way. So manual way is nothing but in general online courses you are seeing, right? So how they teach you? They directly open the AWS console and they created the Lambda and the SQS. This is the way they are showing. But in the real time processor, this is completely different. There is a big picture in the background. So there is an Azure board, GitHub, IDE, code development, PR, merge, and deployment. There are multiple ways. There are different ways. Okay, to build the same structure. But in manual way, like it will take like around 10 minutes. Okay, it will take around 10 minutes. But like a professional way, it will take around sometimes one day. I can consider one day. But here, multiple developers will work. So, like architectures, okay, architectures, team leads, team leads, developers, DevOps, DevOps, QS. So, all these people involved to build this structure. But mostly, if you see it in online, okay, in online, they directly create this structure without following all these steps. Okay, now I will explain two different ways. Okay, let's go to the manual way how it works. Very simple. See here, message receives to the lambda. Okay, so first to create the lambda, let's open the AWS console. If you don't have the account in the AWS console, please create it. After creating, just open the AWS console and the UI look like this. Okay, now you can use this search bar, search for the lambda. Open the lambda. Okay, open the lambda, and you can use the create function, and remember where you are creating the location. Okay, location is also very important. Let's go to the create. Okay, there are different ways. You can use the author from scratch and create one uh, manual lambda. Runtime, obviously, select the Python 3.11. Keep the remaining as it is and create the function. Okay, function has been created. Okay, let me close this. Right. So function created. Done. And what we have to add? The trigger. So the message where from it comes? From the SQS, right? Now again, go to the home page and create the search for the SQS. Create one SQS. Okay. And SQS. See, what is this SQS? How it is useful? I will explain this concept later. Okay. But now, see, it's very simple way how you are seeing the classes in the online, how they are explaining. Okay, that is I am explaining you. Okay, now here manual SQS. Okay, and keep it everything same and create the SQS. Now SQS is ready and Lambda is ready. Now what we have to do? We have to integrate these two, SQS and Lambda. Okay, so to integrate these two, SQS and Lambda, there is an agreement like I am role. In the I am role, we have the role based, okay, role based policy. But let me try to add without the policy. Will it accept or not? Let me add the trigger. So here we are using SQS, right? SQS. Search for the manual and sample. Manual SQS is there. Set the manual SQS and try to add it. Yeah. So the function execution role does not have permission to call receive SQS messages. So what it is trying, it is when we are integrating this SQS to Lambda, Lambda is trying to access this SQS, but this SQS is not allowing to access this Lambda. So what we have to do here, we have to attach the policy between these two. Okay, okay. Let's go here, Lambda. Go back to the Lambda and configurations, permissions. Inside this permission, open this role. This we call role-based permission, role-based policies. And here permissions, we have only execution role. Attach the policy. And here SQS. I'm giving the SQS full access now. Done. Now the Lambda contains the SQS permission. Okay, now let's go to the again trigger and search for the SQS and manual SQS. Now add it. It will allow. See, done. Okay, if you say now how it works, just imagine the message comes from the API. Right now we don't have any API. Okay, just imagine I'm directly triggering this SQS and SQS message goes to the Lambda. Okay, now to test this, open the SQS, click the SQS, directly it goes to there. Okay, and here we have the option like send and receive messages. Okay, let's click on this. You can send a message here, but the message contains in the JSON format. Okay, before that, to receive the message here, I want to display it, right? So to display the message, I will print that event. Okay, so the message comes to here. Okay, and we are printing it here. I already explained what is the Lambda, how it is useful in our uh, course, like in my website, regular Python. Open it, okay, and go to the Lambda lesson. Okay, you will see the Lambda related. Okay, here I'm not going to explain the Lambda. I'm just explaining the flow, how the SQS how the Lambda receives the message from the SQS. This is the concept. After receiving the message, what we have to do, that is the Lambda work. Okay, right. Now changes are happened, so deploy this code. Done. Okay, this one is done. Okay, let me send a message now. Here I'm sending a message. No. So okay, send a message. Message sent. Come to here. Open the monitor. So here we have to see the messages in the CloudWatch. Okay. So this is the CloudWatch metrics. Okay. So the CloudWatch metrics like how many messages received. Okay. How much time it taken. So all this information you will see it here. But this also I will explain it later. Okay. Let's open the view CloudWatch logs. Okay. Yeah. See here we have one log stream. Open that log stream. And this is the message we received from the SQS. Okay, the lambda, we send the message from the SQS, right? The lambda received that message. So that message we printed. Okay, this is the message. So let's see here in the body. What is the message we sent? Name Sairam. So once the message is received to the lambda, lambda will take it to process. That is the next procedure. Okay, that process I explained in the live recordings. Okay, in this project one. So after receiving the SQS message, what we have to do, that I explained here. Okay, forget about this. This one I will explain it later again. Okay, this is complete. Okay, right. So basically, this is the way most of the online classes they teach you like this. Okay, everything they open the UI and they do it in the console. But in the real time, okay, but in the real time process, this is completely not not the good process. It will not work. This is completely wrong. So whatever the concept you are learning, okay, this is completely wrong. But of course, it will give you some knowledge. It will give you some knowledge, but that knowledge is not helpful in the real-time process. Okay, so in the real-time process, this is the way you have to follow. Okay, so what you have to do? First, you have to read the documentations. They will provide the documentations. So in the documentations, like documentations, mostly it's a like conference page. Okay, they will provide some links. Okay, what you have to do, you have to open those links and you have to read the project details. For example, they will share the links like this. Atlassian, my website name regular Python. So if the company names come first, after that this one. Okay, most of the people use the Confluence page. Okay, so Confluence page they will send the project details here. So first you have to understand what is the project. Okay, what we are going to do. Okay, and next they will give the sprint board. Sprint board. Sprint board is nothing but where you have to pick the task. Sprint board. Sprint board is nothing but like someone use the ADO, Jira, or management tools. Okay, there are different terminologies they use to call it. Okay, mostly like Azure ADO board. ADO board is nothing but Azure DevOps board. So in the Azure DevOps board, okay, in the Azure DevOps board, this is look like Azure DevOps board. Here you have the backlogs, sprint, and some other related. So daily you have to visit this board, okay, and you have to check what are the tasks I have to pick to work, okay, and what are the backlogs. There, okay. So for example, this is a backlog, okay. Let me open this backlog, okay, and there is a sprint. Sprint runs every 10 days, okay, like 10 days duration. So let me add this. Okay, let's go to the current sprint. Current sprint. Current sprint is sprint 11. Okay, just imagine sprint 11. Let's go to the backlogs. So daily you have to discuss with your team about this implementation. Okay, this is the AWS Lambda SQS based real-time order processing pipeline. This is the user story. Okay, and you have to bring this user story into the sprint 11. Sprint 11 is already there. Okay, sprint 11 and is already in the sprint 11. Let me check. Sprint 11. Sprint 11. So if I open the sprint 11, see here, this is a user story. You have to create multiple tasks here. Okay, those tasks look like this one. So you have to create task 1, design solution architecture, create SQS queue DLU, develop Lambda function, create a DynamoDB table, set up a cloud formation, create a Terraform. So basically there are multiple developers have multiple tasks. Okay. So for example, let me create one task for the developers. Okay. It's like a dev team, developers, create Lambda, create a repository, create a repository, repository. This is one. And they will give you how many hours, like how many hours you will take to create this repository. Let me take it will not take much time, then take like 2 hours. Okay, 2 hours. Let me take the 2 hours. Okay, and add me one more. Again dev, implement the code to handle SQS request. Okay, implement the code to handle SQS request, and again dev uh, dev write test cases. Okay, these are all related to the developers. Now DevOps, like QA team, here test the code. QA team. Now DevOps deploy the code. Deploy the code. So like this. So first work goes to the developer. Why? Because they have to create first development. After that, only QA people test the code. QA people, once development is done, okay, DevOps people will deploy the code. This is the procedure. Okay, but manually, how you did that? Directly you go to the AWS console and you created everything. But this is not the case. Okay, so this is the way. So here, this is the Azure dashboard. Okay, like we call it a sprint board. There we have multiple user stories, and each user story contains the task. Okay, let me take this create repository. As a developer, you have to pick this task. So then, whenever you pick this task, it means it is in active, and who assigned to this? It's a Sairam. Okay, Sairam is doing this task. Okay, this is my task. Let me do this task. Like for this project, we don't have the repository. Like it is not an existing project. It is from scratch. Okay, there is no repository. So we have to create the repository first. Okay, so to create the repository first, what you have to do, you have to visit the GitHub. Okay, here you have to create the new. So project name, you can suggest any project name. Project name is actually they provide the details under this task. So what a create a repository, create a repository, repos and name like uh let's take I'm not sure e-commerce e-commerce API, sorry, e-commerce. Okay, let me Ask the chat GPT to suggest a best name for this. Give me a best repo name for this project. Okay, let's take AWS order processing pipeline, or else AWS Lambda SQS order price. Okay, anything is fine. Real-time order workflow. Okay, let's take event-driven order processing. Yeah, let's take this best example. Okay, let's create the repository. Done. Create the repository. Okay, and yeah, repository is ready. So once repository is ready, then what you have to do, you completed it in 2 hours, save it and close this task. That's it. Now you have to take the implementation. Okay, this is the actual coding. Okay, so now just think like you are working with the existing project. So existing project, nothing but this one. This is already existing. Okay, you have to implement your code here. Okay, right. So let me add this existing project. Okay. Okay, let's create the new repository. Okay, let's create the project. Take this and go to the PyCharm, like the IDE. Any IDE is fine. Mostly PyCharm is the best option for the Python developers. Okay, let me create the project. New project. This is AWS serverless application, right? Right. I'm going to create the AWS serverless application, Python 3.1 version, and the project name is like, let me take one folder, small projects. So inside the small projects, I will take the project name like event driven order processing. Let me create it. New window. Yeah. So basic skeleton is ready. Okay. Basic skeleton is ready. Let's open the terminal. To run this Lambda code in your local machine, you must and should have the Docker. Okay. So I already explained how to install and run PyCharm codes. Okay, let me open the Telugu. Okay, installation, software installations. Go to the software installations. See here, GitHub and explanation setup and PyCharm AWS cloud integration and PySpark. Okay, so like that you can set it in the English also. Both I'll explain in the both languages. If you are still not aware of this, I will explain it in one-to-one session. Okay, now okay. So first I want to run this project in my local machine. Later I will deploy this code. Okay, so to run this, okay, Docker. So Docker must and should run. Okay. Okay. Now let me run the script. Apply. You must input. Okay. So just imagine like you clone the project from the Git repository and you started your work here. Okay. Yeah. So you are doing your development in the local machine. Okay. Let's wait. I will explain everything step by step. Let me run this. Sorry. So first time it will take around 2-3 minutes. Second time it will not take much time. So what it is doing, it is creating the build file and creating the image for this project. Why it is happening? To test to run the AWS Lambda in your local machine, you have to do these setups actually. Okay. No problem. Let's wait 2 minutes. So manually, it will take very less time, right? We just visit the AWS console and we created the Lambda directly. I think it didn't take much time, around 2 or 3 minutes. But see how much time it is taking. So you have to take, okay, you have to visit the Azure board, create the repository and clone it in the IDE, start the development, raise the peer, merge it and deployment. So this is the actual real-time processor. Okay, so you must and should learn this. Okay, if you learn this, you will get the confidence to how to build the projects in the real time. Okay, see, 200 code means it's working fine. Okay, this is that. Now, what I have to do, the project, whatever the project I'm doing in the local, I have to push the code in the Git repository here. Okay, so first what you have to do, version control is there. Create the Git repository in your local machine. Okay, now commit all the changes here. Add and committed. See, all these concepts I will explain in later. Here our agenda is create the Lambda and SQS, integrate both. Okay, like a professional way. That is we are doing. We are not doing any implementation here. Okay, remember this point. So if you want to learn this concept individually, I will share a link at the bottom. Okay, you can open it and see how AWS, what is the AWS Lambda, what are these files, and how it is useful to us to build the projects. Okay, now here I am just creating the AWS Lambda and SQL. That's it. Everything like a professional way. Okay, now commit to directory. Let me take initial step. Commit. Continue. Now I want to push this code to the actual repository. So this is the first time, right? So that's why it is asking the define remotely where you want to push. This is the code. We have to copy this link. Okay, copy this and open it and paste it here. Okay, yeah, push it. It will ask which Git repository. I have two accounts. So let me. This one is the regular Python. Login with the regular Python. Okay. Now the code is pushed. Let me refresh this code. Yeah. So this looks like whenever you took the project from scratch or else existing project, the project in the Git repository is look like this format. Okay. Now you are going to work on the existing project. Okay. Now how to implement this? Okay. Right. Now what you have to do? Okay. Let's first you have to create the new repo. Sorry. Let me pull the code. Okay. And create the new branch. So go to the master, create the new branch. So how to create the new branch is like it's completely depends on this Azure board. So let me open this task. So here is the task ID and this is the task name. Okay, remember this. So whenever you are creating the branch, so let's take the task ID, okay, and task name. Okay, like uh, let's see, I receive something. This is the branch name. This is the way you have to create the branch name. Okay, task name, task ID, and task name. Some people use the for different folders like features. You can take the features also, no problem. Okay, so I am in this receive SQS branch. Okay, here I'm going to add app.py print same like event. I'm not doing anything. Print event. So whatever we did in the manual way. So this is the Lambda project, and I am just adding the print event. That's it. Done. Now I'm going to deploy this code. Okay. So deploy this code means let me deploy this code into the cloud. So there are two ways to deploy the code. One is like okay, wait. Yeah, there are two ways. There are two ISs. One is infrastructure as code and infrastructure as code. AWS Cloud Formation and Terraform. AWS Cloud Formation is used by the developers to deploy and test the code. Terraform is used by the DevOps teams. So DevOps teams they use Terraform to deploy the code. Both the main purpose of this both are like ISC only, and both useful to deploy the code by using the infrastructure as code. Okay, but AWS Cloud Formation is native for the AWS. Terraform is useful for any providers like AWS, Azure, GCP, any providers. Okay, there are two IAC codes. Okay, here I'm going to use this cloud formation first. I'm not the DevOps team. Okay, I'm the developer, so I'm going to use this AWS cloud formation. So AWS cloud formation is nothing but this template YAML file. Okay, this is the template YAML file. Okay, this is the template YAML file. This template YAML file, I already explained what is the template YAML file, how it is useful. If you are not get, please contact me. I will show you where it is. Okay, or else I will send the link under this video description. Okay. Now this is the template YAML file. Okay, right. Now by using this template like infrastructure as code, we are going to deploy this Lambda into our AWS console, like completely like automatic, like programmatic. Let's open the terminal. Okay, click the SAM build. See, just creating the lambda, it is taking how much time? Okay, just here we are creating the lambda only. Just creating the lambda like a professional way, it is taking this much time. But manual way, how much time it took? Just 1 or 2 minutes only, right? Right. Now SAM deploy. You have to follow all these steps in the real time. It's like a professional way. That's it. So we are maintaining everything in the cloud. See, the code is in the Git repository, and Git repository it's like a version controller. Okay, multiple developers will work on this part. Okay, if you directly write the code in the AWS console, multiple developers can't work on it, and it maintaining the code it's very difficult. So even if you want to test the code here, it's very difficult to test it. Okay, so the development, testing, everything goes to the local. Okay, something is failed. Serverless API in the okay. Some I removed right AWS API. Let's remove this. Sorry. SAM build. No, SAM deploy. So to know this template YAML files information, you just visit my website and go to here view course curriculum and search for what is that? SAM. No, it's a cloud formation. Yeah, this one. Open this lesson and see what is the AWS cloud formation and how it is useful. Okay, like that. Okay, let me click the yes button. What we are doing here, we are just creating the AWS Lambda in AWS console by using the IAC infrastructure as code like AWS cloud formation. This one. So defines and deploys AWS resources in a YAML file for consistent step. Okay, it's done. So deployed professional like a developer. It's not like a DevOps. Okay, developer successfully deployed. Actually, developer what he do? He first he test everything in the local and to confirm. Okay, this one is working or not. What he do? He deploy the code in the cloud. After deploying the code in the cloud, he will start the testing. So let me open the cloud formation. Cloud formation. Okay. See here, event driven order processing. Open this. And what are the resources we created? Hello world function. See, AWS Lambda function. Open this AWS Lambda. And our Lambda is ready. Now Lambda is ready. Correct now? Now what we have to do? We have to attach the SQS. We have to attach the SQS to this Lambda. Okay, Lambda is ready. But manually it take only 1 or 2 minutes. But as a like a professional way, it took around half an hour, right? Why? Because we maintain everything like. So if someone wants to work on this for Lambda, he simply clone this project and he start development. And okay, and what are the project details he want? You just simply visit the Confluence page. And what are the tasks available for this project? They simply visit the dashboard. Okay, this is all comes under professional way. Okay, so it's not uh, like childish. Okay, we should follow all this process. Okay, right. Now the second step is like AWS Amazon SQS to integrate with the AWS. See, once message is received, then you have to implement the code here. This process I already explained how to handle the projects, right? Uh, here at the bottom. AWS Lambda ETL data pipeline project. Okay. So if you want in English, you go here and open it. And you will get the how to handle Lambda after receiving the message. Okay. Anyway, let's add the SQS also. So SQS in the previous how we did, we created a SQS manually and we attach it, right? Here we are not doing anything like that. So here we have the IAC, infrastructure as code, right? So everything will create by using this. Okay. Yeah. Let me attach the SQS also. Let's go to the template YAML file and copy this template YAML file. And I'm going to ask the ChatGPT add SQS trigger to my Lambda function. Okay. Just pass this template YAML file. It will create. This is like a code. What is this meaning? AWS Cloud Formation, by using the code, we are creating the resource in the AWS. Simple. So we have two options like AWS Cloud Formation and Terraform. Both we use to create the resource. AWS Cloud Formation is especially for the AWS. It's a native IAC for the AWS. But Terraform is, if you learn Terraform, you can work on the multiple providers like Azure, AWS, GCP, and there are lot of providers available in the market. Okay, so most of the DevOps people use the Terraform, right? So if you are a native to the AWS, then use this AWS Cloud Formation. Okay, let me open this. Okay, yeah, here it is my Lambda function, and here it is attached the SQS, and this is the queue policy. So this is like a code to create the SQS. Okay, don't worry about this. I already explained this template related information. Okay, let me copy this, paste it. That's it. Now here, let me explain. This is my Lambda function. Okay, and this is nothing but event. So what is the trigger here? SQS event type is SQS and SQS related properties. That's it. Now see here again, SAM build. First do the SAM build and SAM deploy. Okay, yes. So now what I am trying to do? So Lambda is ready. Okay, Lambda created through template YAML file and SQS also template YAML file and integrating both. So everything is happening in the cloud formation. Okay, you can, as a developer, you can use the cloud formation. If you are a DevOps, then you can use the Terraform. So I will explain this in the Terraform also later. Okay, let's see it working or not. Still it is running. Hmm. Taking too much time, right? Yeah, it's done. Now open. Okay, this is our project, right? Previously we created the Lambda. Now we attached the SQS, everything like a program. I haven't did anything manually here. If I refresh this, automatically will come here. See, let me refresh this code. Trigger will add. I haven't did anything manually. Everything like a programmatical edit, right? See, SQS is attached. Let's open the SQS. See, orders queue. Open this SQS and send message. Name something your wish. Program. Just something like program. Okay, send this message. Okay, now go to here, monitor, view CloudWatch. View CloudWatch. Okay, maybe CloudWatch is not enabled here. I think. Yeah, now it can open it. See here, this is the message and see. So what you have to understand, we developed the Lambda code, everything in local. Once everything is done, like development testing is done, we deployed the code and it is in the production. Previously, how we did everything manually. It took around 1 or 2 minutes, but like a professional, it took around 30 minutes. Now your code is done. You tested in local and you tested in the cloud. Everything is done. What you have to do? You have to merge this code to the local branch. Commit the message. Okay. Now push this code. 2 steps. Push it. Okay. Regular Python. And go to the code. See here. PR. This we called PR. You have to raise the PR. Okay. And what you did, you have to wrote all the information here. Then raise the create pull request. Once it is done, okay, so to whom you have to review this code. Here, if you are in the project, if you are in the team, so your team members will appear here. Okay, your team members. So you just request them. So this is the task I done. Please review it. They will come here. Okay, they will come here and they will see what are the tasks you did. Everything. So if they are happy with the code, the changes you did. Okay, so this is the previous and this is the new. Okay, if they are happy with these changes, they will give you the approval. Okay, submit. Actually, I can't approve because I only raise it at PR, right? So they will approve your code. Once you get the approval, okay. Once you get the approval, okay. Once you get the approval, you have to merge this code. Merge this code. Merge this code into the main branch. Into the main branch. That's it. Okay. Once code is merged, okay. Then what you have to do? You have to move from this branch to the master branch. Check out. So if you see in the template ML file, you will not see that SQS. Why? Because the merge is happening in the cloud, but it is not in the local yet. Okay. So to do okay to get this latest code, what you have to do? You have to refresh this branch in your local machine. So pull the code from the master branch. Then in your local master branch will refresh the code. See here. It refreshed and it in the master branch also you have the task. Now after everything you done, you simply go to your board and you just close this task and start new picking again and again start your new branch. Create a new branch from the master branch every time. Don't touch the master branch. This is the way you have to develop the code. Okay, I hope you understand how to create the manual and how to follow the professional way. So if you want more related, like how to implement the code in the Lambda, how to implement the code in the SQS, okay, please contact me. I will help you, and you can visit my website directly. For English, see how Lambda works, how to create the API gateways, what is the ORM, and how to the fast API. You will learn all these concepts, all the projects. So if you learn this concept, you will become the pro in the AWS Lambda projects. Okay. And for Telugu people also available. So go to the Telugu and go to the bottom. You have the projects and live recordings also available. Okay. Right. Thank you. I will share the video and I will share the document also. Thank you so much.